Okay, let's go on to the annuities. Okay, so yeah. So you might recall, it's coming. You might recall that when we work with an annuity, we have a recurring payment. Okay. A recurring amount that I keep on investing or paying, and that recurring amount at least at school, is a fixed amount. So I'm going to put in an amount here, and the same amount there, the same amount there, and this goes on until I get to my last payment or my last amount here at the end. Okay. Now this is important. The proof of this formula, okay, is important. So this is where I'm starting. I'm not investing anything now. I'm going to start in one period's time. So for now I'm just going to say in 1 month's time, so that you understand, but I can change the word month with quarter or year or semi-annual or half year or whatever, but just so we can understand each other in plain language, let me not say time period, I'll just say month. So in 1 month's time I'm going to start investing, and then I'm going to invest in payments. I'm going to invest in payments. Okay, so in months maybe, or in time periods. Now what happens is when I get to my bank account in 1 month's time, how much is there when I get there? Nothing. So I put in an X. So at this time period I've got X in the bank account. When I get there a month later, how much do I find in the bank? If you find nothing, you better sue that bank, they stole your money.
Depends on the interest.
Okay, it's going to be the amount I invested, okay, plus the interest, X plus I, okay, and then I'm going to add another X, isn't it? At the end of that day, I'm going to add another X. Okay? If I get there a month later, and I'll tell you what you will find your first amount, this amount, had 1 month's interest the last time you were there. By this time you get there, it has 2 months of interest. Make sense? This one that you put in last time, he was only there for 1 month, so he only got 1 month's interest. And then there's one that you just invested right now. You get that? Now, the last day you get there, so however long that went, each time, let's just look at the next one to see the pattern going. Okay? Then, so let's just look here. The total amount that I have in my bank account is this first amount with 2 months of interest, the next amount with 1 month of interest, and the last amount. So I'm adding all of these together. Do you see that? To get my total amount. Does that make sense to everyone? So now the first amount is in the bank, and it got 2 months of interest. But I also had a second amount. Maybe I should do a different color, then you'll see. This one was only there for 1 month, so he only got 1 month of interest. And then this last one I'm putting in right here, he's all by himself. Okay? But the total that I have in the bank account, I need to add all of them together. The first month's and its interest, the second month's and its interest, and this one that I just added now. Does that make sense? You sure? Okay, so now when I get there a month later, the first amount has now gotten 3 months of interest. Now remember, this is in the first month, the second month, the third month, this is in the 4th month. When I get there the 4th month, my first payment has only made 3 months of interest. Why only 3? Because in the first month there was nothing in there anyway. There were only 3 months. This first one has only been in there for 3 months by the time I get to 4. Does that make sense? The good one? Are you sure? The second one, this one, has been in for 2 months, so he's going to get 2 months of interest. The third one has been in there for 1 month, so he get 1 month's interest, and then I'm making a deposit right now, and so that one doesn't get any interest yet. Or let's do this, let's put him 1 plus I to the power of 0. He doesn't get any, 0 interest. To the power of 0 is just 1, so it wouldn't have any effect. And again, I must add everything together because it's all my money. Make sense? Okay, so if this is n, what would the expression look like? Well, I would have my first payment. How many months interest will this one have gotten?
Which one, sir?
My first payment, this one. How many months of interest would this one have had? Or let's do it backwards. Maybe that will be easier. In other words, let's do the one that I just added right now. I get to the bank and I put 1 in. The one I've just put in right now hasn't had any interest yet. He's just gone in there. The one that I did a month before, that one has had 1 month of interest by now. Okay, so that one has had x 1 plus I. The one that I had a month before that, that one has had 2 months of interest. Okay, and so there's a bunch that I didn't draw on here. But how many months of interest will my first payment, so that's going to be the very last one in this series, okay, how many interests will he have gotten?
So please repeat that.
So the first one, how many times did he get interest?
And
Can't be n, because it's n, then this would have been, then at this point he would have had 4. Because n represents the months. Tabang, you've been very quiet. What do you think?
please repeat the question.
The first payment, how much interest did he get the first month? Nothing. Because he was just invested. In the second month, he got 1 month of interest. In the third month, he had 2 months of interest. In the third month, in the fourth month, he had 3 months of interest. So in the last month, in month N, how many interests would he have had?
N minus.
Yes. N minus? Minus the months that he wasn't in the bank for. How many months wasn't he there for?
1.
There was only 1 month he wasn't there for. So n minus 1. The one before him, that was this bluish one. He was in the bank. 1 plus I. How many months did he not get interest? 2. So of the total months, there were 2 months he didn't get interest for. Now all of these in between, that's okay, we're not going to do all of them, but in the end I must add all of these up again. So I end up getting an expression that looks like this: x plus x 1 plus I plus x 1 plus I squared plus all the way to x 1 plus I n minus 2 and plus x 1 plus I n minus 1. What do we call this? Who knows?
It's a series.
It's a series. Okay, notice that. And what type of series is this? So we have two options, arithmetic or geometric. Geometric. And if it is geometric, if it's a series, it's the sum of the series. Sn is equal to A1 minus Rn divided by 1 minus R. What is my first term? X. 1 minus, what is my constant ratio? What am I multiplying each term with? 1 plus I to the power of n divided by 1 minus 1 plus I. Okay, does that look familiar? Okay, we're not finished yet. X. Now all I'm going to do is simplify the denominator. You'll see if I simplify the denominator, I get negative I. Now I don't like having that negative I, so what I can do is the two terms in the top, I can flip them around. Remember, if I have something like 4 minus 2, it gives me 2. So if I swap it around, I get 2 minus 4 and I get negative 2. So it changes the sign when I flip a difference around. So if I change the sign in the numerator, I can just change the sign in the denominator. Okay, so this becomes 1 plus I to the power of n minus 1 over, as I said, the bottom was negative I, but because I changed the sign in the numerator, I'll change it in the denominator as well. And there's my formula, and that is for the future value after n payments. Now the whole time you can see I did speak about months, but it didn't matter what I spoke. It could have been months, it could have been terms, I could have just the whole time used a different word. It remains the same formula as long as you remember n represents what? The number of investments. It's how many investments I made. Okay. Often people say number of months, number of years, and they change this formula to have n times m and all kind of strange things. This is the number of investments, and I is my interest per investment. Interest per investment. Make sense? Okay, X is my amount invested, my investment amount. And Fn is just the future value of that investment amount.
So I can ask, this formula only works like, or say for example, if you're in a situation where they said you start immediately. So
if we start immediately, very good question. Let's just see. If I start immediately, then instead of having a 0 here, I will have a X here. And then what changes here? Now all of a sudden I get an extra term. So you'll now see this extra term, after 1 month we have a X plus I to the power of 1. And in the next month I've got an X plus I to the power of 2. Point being that here my initial investment, I would have a X 1 plus I to the power of n. You see, there's one investment that got interest every single time, which means I just have one extra term. Instead of having n terms, oh, here I have n terms. Now the reason why that's a -1 exponent, and that's just an n, is because the first one didn't have an exponent, you see. So now I've got n plus 1 terms. So in my formula here, all I need to do is add 1. Okay, so that is when I start immediately. That's why I say that's the number of investments, because now if I start immediately, I'm going to have 1 extra investment. Does that make sense? Okay. Now let's just quickly, while we're on the subject of the formulas, quickly look at the we've looked at the future value formula. In other words, that's how much money there would be in at this point. In the future, that's how much I will find after that last payment. Now, in a sense, what you could do is you could see, okay, if that's the case, how much money, if I didn't want to invest X amount every year, I wanted to invest one amount in the beginning. I just want to invest one amount in the beginning, and in the end, so let's say this, I'm going to invest one amount right now, you are going to invest every month. Okay? I want to know how much must I invest right now so that I will have the same that you would have in the end. Do you understand my question? Okay, so how would we calculate my value at this point? What would we do to get my future value at that point? What formula would we use? This formula that we used here? Would we use that formula? No, this is for annuities, when there is recurring payments. You guys get that? I only use the annuity formula if there's recurring investment, the same amount over and over. So what formula would we use to work out my future value? A single amount invested bulk.
Isn't it my future value?
The normal future, are you talking about this one? P, so my amount, 1 plus I, okay, to the power of n.
Assuming that you're in the same bank.
Yes, assuming that we're going to the same bank, same interest. Now we want to know how much must I invest to have the same future value that you will have. So this is what the formula will come down to, is your future value is going to be calculated with this 1 plus I to the power of n minus 1 divided by I. My future value is represented by the present value I put in times 1 plus the same interest, the same time period. And we want these two values to be the same. In other words, we want my future value, this is my future value, to equal your future value. Does that make sense? Does anyone have questions at this point? If you don't, you're basically done. Let me show you. So what you're going to do is, all you want to do is solve for P. So we're going to divide both sides with a 1 plus I to the power of n. Divide both sides with a 1 plus I to the power of n. Would you agree with me that I can, rather than putting this value here in the denominator, I could rather move it here to the top and just make the exponent negative? Would you agree with me that's allowed? Does everyone understand why I did that? Or maybe not why I did that, but that's okay. I'm allowed to take a factor, not just a term. It has to be a factor in the denominator to the top and just make the exponent negative. The reason why I did that is because I want to multiply in here. And then you'll see on this side it cancels, and on the other side I now have x. What can I do if I have two bases that's the same? What do I do with the exponents? I'm multiplying this base with that base. What do I do with the exponents, Kalani?
They add.
They add. So I've got n minus n, which is 0. Anything to the power of 0 is 1. I was so hoping someone would shout 0. Anyway, it's 1. Okay. Sorry, I shouldn't have that line there. I've got, so in this bracket I've got a 1 there, minus 1 times that bracket, minus 1 plus I to the power of n, negative n, thank you, over I. And there's that formula. See how easy it is to get that formula? And what does this P represent? It represents how much your future value is actually worth today. Okay, and now another thing that I didn't say is I did tell you that we are that I want to know how much I want to invest in the beginning of the time period. But I can say the same at any point. I can ask, how much must I invest at this point? If I ask you how much I must invest at this point, notice, what do I count? Do I count the time periods that's past, or do I count the time periods that's left over to get to here? Does it matter how many time periods passed? No. It matters how many months are left over. That's going to determine how much I invest now. You understand? So in this formula here, this N does not represent the number of times. So the present value formula doesn't represent how many payments was made. It can't be that. In the present, there's none be made. It's how many payments will be made. Does that make sense? So in other words, this one, in this form, in the future value, yes, it makes sense to talk about past payments. How many payments was made to get to this future value. But in the past value formula, it represents the present value of the future values still to be made. In other words, the payments left. Okay, now this is why this formula gets used for loan repayment, because this is what the bank tells you. Okay, if you give us back X amount in the future, we will give you an amount right now. Do you understand? So they give you an amount right now, and you pay them back with future payments. So we will use the present value formula when we work with loans. If I want to know how much do I still owe the bank, it will all depend on this formula. Simply, how many payments do I have left? So let's say I've been paying, I must pay, originally I'm paying over 5 years' time. That means there's 60 payments. Now, 4 years down the line, I want to know how much do I still owe them. What will I use for N? If originally N represent 5 years payments, so originally I will calculate how much I will pay back, X, and I'll work out if I have 5 years payments, what will N be? N will be 60. But after 4 years, what will N be?
60.
No. After 4 years, how many payments do I have left?
So what do you get the 60 from? I don't understand.
5 times 12, because I'm doing monthly payments over 5 years. Sorry, I didn't really express that nicely, but I wanted.
So you left with 12 payments.
You're only left with 12 payments, because after 4 years I have 1 year left, which means I have 12 payments left. So I can use this same formula. I don't change anything, just my N, instead of being negative 60, it now becomes negative 12, because I only have 12 payments left. Does that make sense? Everyone okay with that? Okay, so let's do some examples with this. There's a lot of examples. This is, especially this topic that asking how many payments do I have left, very common theme in your final exam. Maybe just to show you, let's read a few questions. We're not going to do everything, but we'll just read a few of these questions. Get it a bit bigger for you. Sipukazi bought a house. She paid a deposit of 102,000, which is equivalent to 12% of the selling price of the house. She obtained a loan from the bank to pay the balance of the selling price. The bank charges her an interest of 9% per annum compounded monthly. Determine the selling price. Okay, we'll maybe do this one as an example. I just want to read a few questions. The period of the loan is 20 years. If she starts paying the loan in 1 month after it was granted, do you see that's the normal way of asking this question? We start 1 month after the starting period. Calculate her monthly installments. So there we're going to calculate. Which formula are we going to use? Future value or present value formula? Well, let's first see. Is it an annuity? Are we using one of the annuity formulas? Yes, because she's repaying the loan with monthly installments. Okay, so it's either now the future value or present value formula. Okay, loans are given in the future or in the present? Present. So we'll use the present value formula because that's the amount she's getting right now. How much interest will she pay over the 20 years? How will you calculate that? How much interest she will pay in 20 years. So obviously we've got the cost of the house. Everything that she paid more than the cost of the house will be interest. So we'll take all her, so let's say she's paying back 10,000 Rand a month. She's paying it over 20 years. So it's 12 times 20, 240 times 10,000. That answer you get, you subtract the original selling price, whatever is left, that is interest. Calculate the balance of her loan after the 85th installment. So which formula are we using? The balance of her loan means how much does she still owe? Are we still using the annuity formulas? Helena? We are. That's what I've been teaching you now the last 5 minutes. This formula is what calculates the balance of a loan. Whoa. Okay? When N is still all the payments are left, then the balance of the loan is how much I owe. In the beginning, I owe all of it. If I make one payment, so let's say my payments are 240 payments, now I've got 239, my N is now 239, it will say how much do I owe when I still have 239 payments. Understand? So after the 85th payment, after the 85th installment, all I need to know is how many installments do I have left. I use the same formula, the same X, the same, I'm trying to find P this time. P is the present value after 85 payments. So will I use the 85 in my exponent? 85 represents payments made or payments left? Made. I don't want to know how many payments I had made, I want to know how many I have left. So I'll use the 85 to find how many I have left. Does that make sense? So how many would I have left? 240 minus 85. Okay? Which is 145. 155. 155 left. And that will give me the present value. She experiences financial difficulties after the 85th installment and do not pay installments for 4 months. That is for month 86 to 89. Calculate how much Sipukazi owes on her bond after 89th month. So she owes the bank the amount you just calculated. Let's say it's something like 200,000. For 4 months she makes no payments. What's going to happen to that 200,000? Is it still going to be 200,000 after 4 months? No, why not? The good one?
It's going to accumulate interest.
Now, if you know the answer, why are you so quiet? Okay, it's going to accumulate interest for how long? For 4 months. So, is she making any payments? So, the first thing we need to decide, which formulas are we going to use? Annuity or normal growth formulas?
Normal growth.
Normal growth. Because she's not paying annuities at this stage. The amount, the 200,000, she's earning interest, so that when she comes back after 4 months to make payments, she finds it's not just 200,000 anymore. It's now like 270,000 or whatever. Does that make sense? Okay, so that's what we're going to calculate. How much? She decides to increase her payment to 8,500 per month from the end of the 90th month. So it's just 89 months, so now she's going to start paying in 1 month's time again, so it's the normal situation. Okay, at the end of the 90th month, how many months will it take to repay her bond after the new payment of 850? Okay, so you can now, you know how much she's owing, you know how much she's paying, you know the interest, so the only thing you don't know is N, the number of payments she will make. So that's what you now calculate. How many months will it take to repay? And obviously you're going to get an ugly answer, like N is probably like 24,57. Well, let's say it's 24,012. Are we going to round to 24? No, we have to round up. Because if we round to 24, it's going to take her 24 and a little bit of months. So if we say 24, she's still owing a little bit. Does that make sense? So whenever we answer questions like this, which term is the first term that's bigger than this number? We must round up. We can't round to the nearest one, because the nearest one would maybe still be too little. We want the first month where she has finished paying everything. 24 months, I'm just thinking of values. If it's 24 months, then it would be too little. Okay. Let's read this one with Samuel. Okay, the first one is just depreciation. Samuel took out a loan of 500,000 at an annual rate of 12% per annum compounded monthly. He plans to repay it over 20 years. His first payment is made 1 month after the loan is granted. See, normal situation, I start in 1 month's time. Normal formula. Calculate the value of his installments. Okay, we know how much he's taking out. We know how many installments he's going to make. 20 times monthly installments, so 20 times 12. That's how many installments he's making. We know the interest. The only thing we don't know is how much he's paying every month. So that's the first question. Melissa took out a loan for the same amount at the same interest rate as Samuel. Melissa decided to pay 6,000 at the end of every month. Calculate how many months it took Melissa to settle her loan. So we'll use Melissa's. In Melissa's case, we've got everything except the N, the number of payments that she's made. So we'll calculate N. That will tell us. And again, are we rounding to the nearest value or up or down? We're going to get, no matter what answer we get, because we're working with when is she settling her amount. If I get an answer like 10,000,001, I'm going to round up.
Which is going to be 11.
Which will be 11, yes. Because if I say 10, it's still going to take her more than 10 months. That's basically the answer. It's more than 10 months because it's not just 10. Or it's not less than 10, it's more than 10, which is 11. Okay. Who pays more interest? How would you calculate that?
We compare both of them. Melissa's and Samuel's, and then compare them.
What would you compare? Because both of them take out the same amount of the same loan with the same interest rate. So what are you comparing?
Oh, yeah.
Payments back.
Payments back. Who will pay the least interest?
Oh, Samuel.
If you so sorry, no, I'm not. I mean, if you compare payments, how would you know who pays the least interest? So in other words, you say you're comparing payments.
Yes, it's
The X values. So which one will pay less interest? The one that pays more or that pays less every month?
More.
The person that pays more every month will pay less interest. Why? They say justify your answer.
because
You finish faster.
Faster, very good. That's better. Instead of calculating, instead of comparing who's paying the most, look who's going to finish quicker. Because the person who's going to pay longer is going to pay more interest because their loan is earning interest for those extra months that you finished paying. Does that make sense? Okay? Alternatively, you could have done what we did before. We work out the total payment because we know she's paying 6,000. Let's say in 10 months she's finished paying. Well, it's obviously wrong, but okay, it's going to have to be much more than that. 6 times. Let's say it's 6 times 100 months. It's going to take her 100 months to pay back. Then we'll take that 6,000 times the 100, which gives me 600,000. But she took out 500,000. So we'll subtract that. Whatever we've got left, that would be the interest. Does that make sense? Okay. And we do the same with him. We take the amount he pays, the number of times the number of payments he's made. That's the total amount that it cost him. But minus the loan that he took out would give whatever is extra there would be the interest. Does that make sense? Sunday? You get what I'm trying to explain? And then you just compare those two. And your calculation would be a justification. Because you've justified it with a calculation. For 2 marks, I think I prefer the one that says the one pays it back quicker, so there's less months to earn interest, something like that. Okay. Okay, let's see. Now, this is NOMSA started working. NOMSA started working on the 1st of January 1970. At the end of January 1970 and the end of each month thereafter, she deposits 400 Rand into an annuity fund. She continued doing this until she retired on 31 December 2013. Determine the total amount of money that she paid into the fund. How would you calculate the total amount of money that she paid into the account? Would it be an annuity formula? Would it be a growth formula? Would it be something completely different? Do you agree, Inka?
so it's written in YouTube.
Yeah. It's written.
Yes, and it's 2 marks. That's why both of you would get 0.
Oh, so.
Just because they say ingenuity. Guys, they didn't ask determine the total amount in her fund. They asked determine the total amount of money that she paid into the fund. Do you understand? It doesn't include the interest that she earned. It's not asking how much is her annuity worth or what's the future value of her annuity. It's just me asking how much money did she herself put in.
So it's isn't it the number of years times the amount?
Yes, not the number of years because she did it monthly. So you can't. I think what is it? 43 years. So from January 1970 till the end of 2013, that would be 43 years, but she does it every month, so it's 43 times 12, and then every month she does 400 Rand into that account. Guys, the mark allocation gives you a lot of information. Okay, if it's just 2 marks and you're trying to use an annuity formula, you know you're wrong. Okay. The interest rate on the fund was 8%, compounded monthly. Well, should have known you can't do the formula because you don't have the interest yet. Calculate the value of the fund at the time she retired. Do you see the differences in the question? How much did she invest? And the other question is, what is the value of the fund when she retires? So now what will we use? Annuity formula. Are we trying to work out the present value or a future value? It's future value. We want to know the value after she made payments, not before she made payments. Does that make sense? Okay. So we'll just use an annuity formula. We've got everything to just substitute and we'll get an answer. On the 1st of January 2014, NAMSA invested, so that's now the very next, in 1 month's time. Okay? No, it's not. She invests 2 million into an account paying 10% per annum compounded monthly. NAMSA withdraws a fixed amount from this account at the end of each month, starting on the 31st of January 2014. If NAMSA wishes to take monthly withdrawals from this account for 25 years, calculate the maximum amount she can withdraw at the end of each month. So let's just talk about this. Is this a normal growth? Is it an annuity? Is it, in other words, annuity would be, is there recurring payments, withdrawals, repayments, investments? It's an annuity. So now we need to determine, is it a future value annuity or present value annuity? Now, the present value formula is always used with loans. Doesn't mean it's only used with loans. Do you understand? Just because this is not a loan doesn't mean we don't use the present value. Okay? We know, depending on where is the big amount. Is it at the end of our payments or in the beginning of our payments? So in other words, the 2 million that's in question here, that's either a future value or an initial value. Care for your soul. If you make X equal to 2 million, I'm going to hunt you down. Students do that. If you make X, if you make your recurring amount 2 million, you are saying she's investing or paying back 2 million every month. Okay, be sensible. So the big values are usually either my future value or my present value. My question is, at what time does the recurring amounts come? Afterwards or before? So if you were to draw a number line, where would you put the 2 million? At the beginning of her withdrawals or at the end of her withdrawals? At the beginning. She's putting that money into the bank and withdrawing it, which means that 2 million is a present value and she's going to withdraw from it. Each time she withdraws, the next month it earns a little bit of interest, but she withdraws again until it ends up being finished. Does that make sense? So it's still a present value. So in this, we have our present value formula, we have our P, we have our interest, we have our, she wants to do it for 25 years, so we have our N still represents the number of withdrawals, in this case because she's withdrawing, so it's monthly for 25 years. And then the maximum amount that she can withdraw is in the end, the X value we're trying to calculate. Okay. But then again, at least 2 people are going to put 2 million as her into the future value formula, so they're probably going to get something like Bill Gates's net worth as her monthly withdrawals that she's making every month. Okay. Yeah, you're right. It's all about understanding and just thinking about it. Okay, let's do that first question together. I think it had quite a few elements in that will be helpful. Okay, so Sipukazi bought a house. She paid a deposit of 102,000, which is equivalent to 12% of the selling price of the house. She obtained a loan from the bank to pay for the balance of the selling price. The bank charges her an interest of 9% per annum compounded monthly. Okay, so here's the first challenge I want you to do is to calculate the selling price of the house. You know what a deposit is, and you know the deposit was 12% of the selling price. So calculate the selling price of the house. Test yourself. After you found the selling price, multiply it with 12% and your answer must be 102,000. Okay, Takuta, will you tell us how did you get that? Well done, by the way. It's not only 1 mark. Sorry?
It's only 1 mark.
Yeah.
1 mark could make a difference.
Yeah, it's just 1 mark, but it is not it's not a trivial question. So how did you do it?
102 divided by 12%.
102. Okay, now let me show you why I did that. We don't know what the selling price is, isn't it? So let's call it P. We know it's going to be the present value later on, okay? But, well, not really, okay? But let's call it SB. Okay, the selling price. If I multiply the selling price with 12%, I must get 1,200. So all I need to do to get the selling price is divide both sides with 12%. And that then gives me 850,000. Okay. The period of the loan is 20 years and she starts repaying the loan 1 month after it was granted. Calculate her monthly installments. Okay. How about you guys try that? Okay, what did you guys do? Sunday, what did you do? Formula?
I used present value formula.
Okay, good. Present values, X. And remember, you don't get a formula sheet. So now this formula off by heart. Over I, yes.
So in the final exam?
Yeah, in the final exam you get one, but not in the prelims. Yeah?
And I said 850,000.
Oh, was that correct?
For present. I don't know.
Was the present value 850,000? Did all of you use 850?
Yes. It was supposed to be 730.
Well, 730. You subtracted 120. Yeah, it should be 102 you subtract.
Yes, 102.
So it's 138.
I subtracted 102 from 850.
Yeah, and then you got what?
730.
It can't be 730, it must be 738. No, 748.
Yes,
748. The selling price is not the loan amount. You get that? Selling price, we still have to deduct the deposit. Okay. X is what I'm trying to calculate. The period, calculate her monthly installment. 1 plus I is 9% per month. So there we go. And we know it's over 20 years. So over 20 years, how many installments would she make? So negative 240 divided by 9 over 12. 100. And so what did you get your X value as? So you say 6729.95. Cool. Okay, how about you guys calculate for me now, how much interest will she pay over the 20 years? Round your answer to the nearest rand. Okay, so that's her repayments. I don't know if the rest of you got the same amount. Okay, with that repayment, she can work out what is the total she paid, and if you subtract then the amount, the present value from the total amount that she pays, you get the interest. So do that. Okay, did you guys get an answer? It's a very simple calculation. Who got an answer for me? Tabang, what did you do?
I'm confused between the present value. Which one? Like, do you mean which present value?
Oh, that doesn't matter. Let's start by how much did she pay in total? So she's paying monthly this amount. How much did she pay in total?
Over 10 years.
Yes.
For me, it's not like
no, I think it's much more than that. So she's paying, guys.
I think she's paid 34.
Sorry?
134,500.
Like that? 500 in?
599.
134,599.
But it's wrong because I took the answer and I multiplied by 20, but I don't know.
Okay, it can't be that, but you're on the right track. It can't be that because she's not paying that amount yearly and it's 20 years. Guys, please just think. Financial maths is really simple, but you have to think. So she's paying this monthly for 20 years. How much is she paying in total? Yeah? More than that. 1 point. How much? 1 and 15. Yeah?
188.
188.
0.036.
Okay, that's closer to it. All those of you that got clothing accounts and debt and want to buy new cars as soon as you can afford the installment. Okay, that's just how much you paid. How much of that was interest? So what must we take away? How much of this was not interest? How much was actually just loan? Minus 748,000.
Somebody they charge you for days.
So
For y'all that's like they make your mind.
banks are ripping people off, eh? Banks are ripping people off.
Yeah.
But everyone I know is falling for it. So you can't accuse the banks.
So it's money laundering, sharp.
So the answer is?
867188.
How do they get the median? Because I'm still struggling with that.
86.
Okay, so Masande say he doesn't know how they get that. Remember Masande? How many times does she pay this?
20.
No.
Oh, how many times? 240 years.
Yes. No, not 240 years.
No, times.
2 times.
Yes.
Yes. Now if she pays this 240 times, that's why we take 240 times this.
Okay.
Yeah, see, that's where the word times come from as well. Okay. Great. They put these questions in so that people start opening their eyes to how ridiculous it is to take out loans.
So now, if you want to buy a house, you don't want to loan from the bank, what do you do now?
You rent.
Renting also.
You rent.
I do.
Then you're not gonna. You're gonna be living there for rent for years, and then you don't have a house. But if you pay for the house and you finish it, then it's gonna be your house.
It's not your house. Hey, Johannes, how are you?
What are you?
Good, thank you. It's only your house after 20 years.
And you don't know if you're gonna be living there for 20 years.
Yes,
Even
definitely.
if you buy it, it's just the same as renting.
No,
Because you're still paying.
you're just paying the bank your rent.
Yeah.
And the only difference is if you can't pay, they can come and take your car. While if you can't pay your rent, your landlord, he can only kick you out.
Yeah.
So but the way I'm doing it, my wife and I, we started businesses, and hopefully the business can grow to a point where the business can buy a house cash, and then we'll rent from the business without interest. So in other words, we'll kind of loan the house from and pay back interest monthly, and that way and even if we pay the business, it's our business, so it's okay. Okay, calculate the balance of our loan immediately after the 85th payment. Okay, so again, do that calculation for me. Calculating the balance after she's paid back. Okay, you know how to calculate it.
Oh no, I want to write the answers.
Yeah, but you can write it on your paper.
But I can't.
Okay, let's
30,000 rand. 30,000 rand.
per person.
It says $2,000. So it's
Yeah, it's roughly. No, that's 30,000 for South Africans. So, how did you guys calculate the outstanding balance? What formula did you use? It's what I've been teaching the whole morning, and still I can't. I saw Petra did it right, so let's follow her advice. So Petra, we use the present value formula, because if I want to know how much money I have in the bank, the annuities that I'm considering is the annuities left. It's how much I must still make. Okay, how many payments I must still make. So it's this formula where n represents what? N represents number of? No. A number of payments left. It always represents number of payments left. Always. The only time it doesn't is in the future value, where it means the number of payments made. In this, it's the number of payments left. So future value is what we're trying to find. Sorry, the present value is what we're trying to find. We know we've calculated her monthly installments, which is that 6729.95 times 1 plus interest, 1 plus, what was the interest rate? Was it 9%? Yeah. 9% over 12. How many payments are left?
155.
Thank you, negative 155. Okay, divided by, and then what answer did you guys get? Petra?
615
Yeah?
509 7.7512
Comma 7
512.
1 2. Okay, so guys, again, this amount, just compare it. She's made 85 payments. From there, after 85 payments, she's not even paid 150,000 off. And 85 times 6,000, 185, so almost 200. She's almost paid 300,000 off. Okay. Next question. She experiences financial difficulties after the 85th payment, so that's why we calculated it in this question. After the 85th payment installment, and did not pay any installments for 4 months. that is from month 86 to 89. Calculate how much Sibukazi owes on her bond at the end of the 89th month. Okay, how about you guys try and calculate how much she will owe now at the 89th month. Okay, so how did you do it? Who did it? Masanda? Melina?
I used the compound.
Then you did it perfectly.
Yeah.
So let's see, you took what value did you take?
The balance.
The balance, so this amount, is that the one you took?
Yes.
Okay, and then what did you do with that amount?
1 plus.
That amount? Yeah?
Explain 89.
89? Okay, so did you draw a timeline?
No.
Oh, then they lost all the marks if I marked you. Okay, so guys, look here. On 85, this is the amount that's in the bank. This amount here is what's in the bank on month 85. Now we want to know what's in the amount in the bank at 89. So are we adding interest for 89 months? How many months are we adding interest for?
4.
Only 4 months.
So just 4.
Just 4. Because it's just 4 months that you couldn't pay. So for 4 months, this is the amount that's in the bank that she can't pay. So for 4 months, it's just getting interest. Does that make sense?
No. So because you can't pay, they still take
Interest. Yeah.
more interest.
Yeah.
But they already put interest.
No, it's not extra interest. It's just the normal interest that you would have gotten anyway. But when you pay, for example, this 6 of this amount that you pay, probably only about 700 is paying your loan. The rest is paying your interest. Okay.
What? No,
Yeah, it's
no
crazy.
way, sir.
It's really crazy.
How do they get away with this? So,
Cool. Let's go. Let's go with this one. She experiences. Okay, so in other words, it should have been only 4 months that you should have added, and then what would you get? With only 4 months, after 4 months, she owes how much? Oh, come on.
634.
634.
1.
Yeah.
83.
83.
8048.
Excellent, thank you. And then, so they did ask to calculate, was that round to the nearest rand up there? Okay, that's not important. Okay, she decides to increase her payment to 8,500 per month from the end of the 90th month. How many months will it take to repay her bond? Okay, so this is how much she now owes. Okay. How many payments does she still have to make? We don't know, but she used to pay this much. That amount there, we had that amount there. Now she's going to increase it to 8.5. Okay, it doesn't change the amount she still owes, but it does change how quickly she will pay it off. Does it make sense? Because she's now paying more at a time, so she can pay it off quicker. So which formula will we use? Are we going to use this value? Is that the value I'm trying to pay off? Yes. Is this value, is she paying it off with installments? Yes, so am I using an annuity formula? Okay, is it the future or the present value annuity formula? Present, because the value I'm trying to pay off is the value that we owe now. The payments come after. So I'm going to use present value formula, which is the x1 minus 1 plus I to the power of negative n over I. Present value 634,183,8048 is equal to, and then on this side I know I'm paying 8,500. 1 minus 1 minus 9, 1 plus 9 over 12, and then to the power of, what am I putting here? Yes. That's what we're trying to calculate. Okay, divided by, okay, your turn, solve for n. Okay, so let's have a look how we go about to solve for n. We multiplied both sides with I'm going to multiply this with the denominator, 183,804 times the denominator, and divided by that 850, 8,500, yeah.
Where's the nearest downside?
Please. Okay, so this. Now notice here we've got again that thing where we've got two terms, but if I take the negative that side, it becomes -1, isn't it? The +1 if I subtract it on the other side, but then I still have the negative. So rather what I do is I flip the terms around. Instead of having this -1 and on the other side I have -1 plus 9 over 1200 to the power of -n, instead of having it this -1, I just flip these two terms around, 1 minus that, and that gets rid of that negative on that side. Okay, again the same thing. If I had that 2 minus 4 is equal to -2, that's what I had here, something minus something is equal to negative something, I can just flip this around and then have the positive answer. Okay, and then how do we solve this? Logs. So -n is equal to log, my base stays my base, 1 plus 9 over 1200, and inside here I now have that expression 1 minus 634. You see how nice it would have been if you used your recall, store and recall buttons here. Okay, what answer do you get?
1.
What?
-1 or 9.74. That's what I did.
-1. 109. Oh, sorry. -109, comma 74. Okay. Okay, now that's fine. So in other words, n is roughly, okay. So when will she? That's the question. After how many months will it take her to pay off? Okay, so roughly 1,974 months is how long it will take her. But so you can say something like she will make her last payment in the 110th month. Okay, you can answer something like that, but this answer up to here should be acceptable. Okay, her last payment, is her last payment going to be 8,500 Rand? No, because a full payment, in other words, if this answer was exactly 110, then the answer would have been, or her last payment would have been 8,500. But because it's less, it means her last payment, she doesn't owe a full 8,500. Does that make sense? I don't know how much it will be actually. Well, how would you determine it? You will determine it with this formula. Okay, 8,500. 1 plus I to the power of, how many payments does she have left?
3.
No, it won't really. No, this won't work. Sorry, it won't work. You could, but you could, if you knew. No. Yes, you would. Okay, but her last payment left. Her last payment left. If we want to know how many payments she has left, after her 109th payment, she only has this many payments left. Negative 0.74 divided by I. Assuming I'm putting I as 9% in there. Okay. So in other words, once she's paid 109 payments, she only has that 0, so it doesn't have a full payment left. If this answer is 1, your final answer would be 8,500. Because that would be her last payment, just the last 8,500, but it's not 1. So, and even if I put a 1 in here, the thing will simplify. Because if I put a 1 in here, and that's a negative, sorry, it would be 1 minus 1, which would be 0, plus I. So I'll just have I divided by I, would just be 1. So whenever there's 1 payment left, I'll just have my X as my outstanding balance, which makes sense. My last balance is my last payment. But now it's not 1 payment left, it's this much payment left. That's an interesting question. I'm going to put that question in somewhere. Huh? I will. It's a nice question. Okay, anyway.